for RF, I think there's two tools that I would suggest, and depending really on your price range. One would be HackRF. It's a few $100s for a software-defined radio. It's very very powerful for its price, and I'm really interested in low price technology. So I'll invest my own money in high price stuff, understand how stuff works, and then figure out a way that I can find lower cost tools so that I can share that with other people that they can use and perform the same types of things. And HackRF is awesome because it can transmit and receive from like something like a megahertz to 6 gigahertz, which covers all sorts of things. So that includes protocols, bands like Wi-Fi, Bluetooth, both 5.8 5 gigahertz and 2.4 gigahertz Wi-Fi. You may not be able to transmit at the speed or hop at the speed unless you write firmware, but you can still see some packets. And then all sorts of low frequency stuff, so like FM radio, like we said earlier, like 102.7 megahertz or whatever. Cars, you might be able to do GPS with it. Now, if you don't want to invest a few $100s up front, then you can get something like a $10 or $20 US software-defined radio called RTL-SDR. So these are really cool. These are actually made for, back when we had analog air TV, these were made for that. So it would basically sniff the whatever UHF, ultra high frequency TV signals from the air and then run it through your computer. But your computer's software did the decoding. So someone figured out that it was actually the software doing the decoding, not the hardware. And all the hardware was doing was sampling the RF and then sending it as, they're called IQ samples, which is really just like the amplitude and the phase. Amplitude just means volume. So I think of it as sound. Like, I think of it, amplitude as volume, and I think of the phase. The phase is where you are in, say, a sine wave. If you're sending a 100 megahertz sine wave, where you are in that. And that really is just a wideband receiver. Well, not wideband, but it has a wide bandwidth. So you can change, or wide operating range. So you can change what frequency you can. I want to listen to 100 megahertz, or I want to listen to 1 gigahertz. And I think RTL-SDR goes up to like 1.7, maybe 2 gigahertz, depending on the type you get, the tuner you get. But it receives only, so you can't transmit with it. But it's for $20, $10, I think it's very powerful for what it does, and is a great way to get into it. And there's plenty of software out there. GNU Radio is an amazing signal processing platform. GQRX is software for seeing the spectrum, so you can visualize the spectrum, like a waterfall plot, so you can just see what's happening. I think
this is 2 quartz crystal oscillators, and so these are these little metal cans that they have in electronic equipment, an oscillator,
right? And
the quartz crystal is exposed. I cut the top off, and you can just barely see the quartz crystals in there. It's the round thing with the electrode on there. And I'm running both oscillators. They're both the same frequency, or they're spec'd to be the same frequency, but they're beat together and then amplified. And so I brought a little audio amplifier. Okay. So the trick is that quartz is actually very temperature sensitive. And so if you just put your hand near one, you hear the frequency change, or if you blow on it. So it's a really fun kind of interactive little project where you can blow on the quartz crystals or touch them with your hands, or just sort of get near them, and the heat will change the frequency. And it gives like a really hands-on feeling of how unstable quartz is, because it's so temperature sensitive. So a lot of times these high-end pieces of equipment have either a temperature compensated or actually an oven temperature controlled quartz crystal. And this is why. And it's really cheap too. You can buy those little quartz oscillators for a couple bucks and just cut the top off, and there it is.
That is so cool.
So this is kind of the whole point of my blog is, unfortunately, with how complex and intense of a tool set they are, and then also the fact that you're typically running this on something like a Linux host machine, and because there's all the different versions and different version drivers of the OS itself that it's running on, that kind of is what a lot of that stems from. That's why a lot of my really popular tutorials, I will make a new one every single time a new version of Vivado/Vitis comes out. I typically am a little bit more careful about upgrading OS. I think if you're a Linux user, you don't want to upgrade to the latest version immediately, like, because I just recently updated to Ubuntu 20. I'd been on 18.04 up until very recently. It wasn't until kind of some of the Creo robotics stuff. Definitely look for tutorials in your specific version, and then be aware and get kind of a sense for what are the main differences between some of the different versions of Vivado, because it could also be a difference in features of your OS. Because yeah, you do get to the point that your only option is to have multiple versions of Vivado / Vitis installed. I'm a huge fan of VMs. I would highly recommend learning how to set up and use virtual machines. And I actually found some really awesome external hard drives. These are only about $100 to $120, depending on the size you buy, these little SanDisk solid states, and they're USB-C. So I'll install multiple versions of Vivado on these guys. And then also I have one of these is my Ubuntu 20 VM, and one of them is my Windows 10 VM. So I highly recommend using VMs to make, if you get to a point that you're like, hey, I just can't get this to work in this version, and I can't find a tutorial in my particular version, I recommend throwing together a VM, which I do cover those, that setup as well, how to set up your VM. Mine are all in Parallels, but I know there's tons of good tutorials out there for all the other stuff like VMbox.
It's a reflection illusion. It's an old stage magic illusion. I think it dates back to the mid to late 1800s. I believe the technique was popularized by John Pepper, and the stage act involved, an actual stage and then a giant piece of glass that would be reflecting something off stage. Okay, so this would make it appear as though there was some kind of floating apparition on stage with whatever actor was interacting with it. But this one is coming from an oscilloscope, if you can see it. So there's the oscilloscope screen, and this is a very small Pepper's Ghost. So this is a repurposed snow globe, and then inside it is just this reflector, polycarbonate, that I cut down, and it lives in there at an angle, and it's reflecting. So it's similar to the stage act, where there's a piece of angled clear or something or other substrate, but this is much easier to deal with and doesn't require glass. And then you can just use your phone. You don't have to get a big oscilloscope or a giant TV. You can just use your phone, and that way anything that's black will become transparent in the thing, and then it'll look like it's floating, and you can amaze your friends. And I've been using my synthesizer to manipulate the image with audio, and I use this live performance software called VDMX for that. And it's used, it's kind of an old VJ software, basically. You can bring audio into it and then trigger different parts of the audio waveform to anything, buttons and that you can set up inside the software, or sliders to make things move. It doesn't take long before you can suddenly, make your voice, or make a drum machine manipulate video. It's a stack of Moog semi-modular synthesizers, and you can plug them all into each other, and they can all talk to each other and work off each other in this weirdly organic way. And then when you feed all those individually and together into the video software to kind of make things move around, as soon as I saw something that I put on the screen wobble to sound, I was like, oh yeah, I'm going to be doing this. This is what I'm doing. Yeah, it kind of feels alive sometimes.
Yeah, so this is our latest robot. It's a robot that I designed with two of my mentors who are also indigenous. We all are from different tribes, so it was really special to be able to do. And I actually have one right here. Well, I have a bunch. But the scope are wearable indigenous language learning robots. And I have been seeing wearable robots like yours for ages, and I finally was able to make one, and it was so cool. It was such an amazing experience because I didn't know if I was able to do it. I didn't know if I had the skills to be able to do it because I've been out of school for a while now. I run the company every day, so I haven't finished a degree. So I was like, oh my gosh, I don't know if I know how to do this. But I put a lot of learning in, and we were able to create this. And it's a robot that's run on an Arduino Uno. And it's wearable with a GoPro strap, which is super cool. I will show you, actually. So this is the GoPro strap. And what's really neat is that it just connects right on underneath it. And we print all of the robots in like out of recycled PLA. But then the robot just goes right on. And we design these for our students. And right now it's a prototype, but we're going to be rolling it out real soon. And it lights up and it speaks. As you can see, there's a PIR sensor here, so it senses motion, and it lights up and starts speaking. They're all decorated in very different ways to reflect our cultures. And mine is pink because I love pink. Super cute. And so each part is like 3D printed separately, and this is what the head looks like, or as I call it, the little skull. And then this is like what the base looks like. It has scope box on it. It has some beading. It has some hexagon holes in it for like the sound to go through. And then I also have my circuit guts in here, which is what I was filming with. We also put a Bluetooth speaker in it sometimes to play like music, which is a bit simpler. Got my Arduino Uno. I've got my speaker. I use one of those big speakers. And this is my favorite part. So we have a micro SD card reader and also a micro SD card where we upload all of the files that the robots are speaking to it. And then we just connect that to the circuit. So we got it right here. And our PIR sensor. I'm sure all of you know what those look like. My favorite thing, the baby breadboards, as I call them, or at least the students like to call them. The circuit's not too heavy. It's pretty simple to code, pretty simple to adapt. And something that we use for the ring light kind of effect that we've been liking is the Circuit Playground Express from Adafruit. And we just stick a battery pack on it and let the kids program it with their own like patterns for the lights. And it's very simple for the kids. It's also very cute.